Welcome to chapter number 9. In this chapter we're going to do triangles. Now we already know that a triangle is a three-sided figure. This also means that it has three angles. What we want to understand in this lecture is that when you add up the three angles inside a triangle, they must always add up to 180 degrees. There's no other way about it. Just add them up, they'll always come to 180. So let's take a example of a triangle. This is a three-sided triangle. Well, all triangles are three-sided. So it has three angles inside, and we're going to name them as A, B, and C. So if let's say we have one side as 90 degrees, the other as 45, we already know two sides. Can we find out the size of the third angle? Well, it's pretty simple. We know that all three of them are going to be equal to 180. Let's try to find out the size of angle C here. So C equals 180 degrees minus 90 minus the 45 degrees. So C equals 45 degrees. Let's take another one. Here we want to find the size of angle B. Can you do this? Let's try to do this. Well, the angle B is 180 minus 55 minus 50. This means that angle B equals 75 degrees. Now there are four kinds of triangles, right? Let's go through each one of them. These are right-angled triangles, equilateral triangles, isosceles triangles, and scalene triangles. We already know what right-angled triangles are, right? So this is a right-angled triangle. We can see this sign right here that shows us that this is a 90-degree triangle. Now it could look in a slightly different way, just turning this picture around, changing the degrees. It could look something like this. It also could be something like this. The important thing is that we want to see something like a box which shows that this is 90 degrees. Now a right angle triangle is basically it's basically a straight line, right? And then this angle, when they say it's 90 degrees, basically this line is perpendicular to the other line. So you could take any one of these two lines that are on this box and they are going to be perpendicular to each other. So in example 1, which is this one here, we know that the total is 180, this is 90, this is 45, so we can calculate what C is. C equals 45 degrees. Now I want you to go ahead and pause the video and try to do all three of these because I am going to solve them for you right away. So moving ahead, in example number 2, C equals 180 degrees minus the 90 minus the 40. So C equals 50 degrees. The next one, C equals 180 minus 90 minus 35. So C equals 55 degrees. And in the last one, 180 minus 90 minus 30 equals 60 degrees. Equilateral triangles have three equal sides. Now if it has three equal sides, the angles are also going to be equal, right? So this is the main property of the equilateral triangle. So you always need to remember, if it has equal sides, the angles must be equal. How about if we don't know whether the sides are equal or not, but we're given inside the triangle, it shows us that the angles are equal. So You need to remember that if the angles are equal, then the length of the sides must also be equal. So they both of these properties go hand in hand. Let's take a look at this example. So here we have a triangle. We are going to name it as A, B, and C. And then these red lines basically denote that this side, the side AB, is equal in length to the side BC, because AB has this line and BC also has this line. Both of them are equal. And then we go ahead and we put the same line over here between A and C. That means that AC is also equal. If the three sides are equal, then it's an equilateral triangle and it also has equal angles inside. So AB equals BC equals CA, and the angles are also equal. Let's do this. Okay, so we have another equilateral triangle. We haven't really measured the sides, but these markers, the red lines, give us an indication of whether the three sides are equal or not, just as in the previous example. So when we see that the three sides are equal, we know that the angles must also be equal. So if I were to say or ask you, what is the size of angle B, right? So you look at the triangle, it is equilateral, therefore B is also equal to 60 degrees. An isosceles triangle must have two equal sides. So if it has two equal sides, then it must also have two angles that are equal. We're going to take a look at an example here. So we've got A, B, and C. This is the triangle. There is one angle right here, and there are two markers on both of these sides. So when you have these, we've just discussed this. When there is a marker right here and here, it denotes that these two sides are equal. So now that we understand, we know this, the important question is which angles are going to be equal, right? Well, the angles at the end, right? So both of these lines are meeting at the point A. This one goes A to B and this goes A to C. The angles at the end, right? This angle and this angle, these two are going to be equal in size. And so we can mark these two angles. Now an isosceles triangle can also be a right-angled triangle. Okay, we're going to mark these two lines, two markers, which will tell us which sides are equal. If we're given the size of one angle, we can easily find the size of the remaining angles, right? Let's say we're given a right angle triangle as shown right here, but they haven't mentioned or they haven't given the size of any particular angle. They don't say that this is, they don't give us in degrees here or anywhere in this triangle. We can see, however, that this sign denotes that this side is equal to 90 degrees. So we can calculate the size of the remaining angles. How do we do this? Well, we know that this is 90 and the three sides are going to be 180. So 180 minus 90 will give us 90 degrees. That means that this side here and this side here should also equal 90. And since these sides are equal, then these two angles must also be equal. And if they're equal, all you have to do is divide the total by 2, which will say that each side is equal to 45 degrees. Let's take another example here. So we have the isosceles triangle ABC. There are two sides that are unknown to us, which is angle B and angle C. That is what they want us to find. Okay, we are saying now that since these two sides are equal, AB and AC are equal, then both of these angles must also be equal. So B equals 70 degrees. And when we know the sides, two of those sides, we can easily calculate the size of angle C. Angle C is 180 minus this 70 here and this 70 here, which gives us 140. So 180 minus 140 will give us 40 degrees. Now, scalene triangles do not have any equal sides. So all the angles are different from each other. Let's recap. Equilateral triangles have all three sides that are equal. And then isosceles triangles have two sides that are equal. Scalene have no sides that are equal, and therefore no angles are going to be equal. Let's try to find some scalene triangles. Now I put on 4 triangles on this chart. We'll go one by one, starting with this one here, and see whether this is scalene or not. Well, this is 90 degrees. This one is 30 degrees. What is the size of angle Z? So Z is going to be 180 minus 90 minus 30. So this should be 60. If this is 60, then all three angles are different. Therefore, this is a scalene triangle. But we also note that there is a right angle right here. So this scalene triangle is also a right angle triangle. Okay? Now I want you to pause the video, try to go through the remaining 3, and then when you've done that, come back and play the video and see whether you get the angles, whether you get this right or not. Okay, so let's move ahead. Let's move with this one here. We have 67 degrees on one side, 58 on the other. So this is obviously not equal, right? So all three sides are different from each other. So this is a scalene triangle. Let's move over to this one. We have two sides. They have marked this with a marker. These two sides are equal, so it's quite obvious it cannot be a scalene triangle. It has to be an isosceles triangle. And in the last one, even though we have a rectangle, the kind of the triangle that they want us to look at is this one that is marked by the red line, this divider right in between. This angle is 90 degrees, this one is 35, and we want to find out what this one is. So if you go ahead and do this, you will find that this is a scalene triangle, but it is also a right angled triangle. And this brings us to the end of this chapter. We will do a short quiz now, and I'll see you in the next one. Bye bye.